Welcome to your first video of the course. Let's get started. In our last section, we introduced the notion of the limit of a function and discussed how to find a limit given the graph of a function. In this section, we will begin to learn how to find the limit of a function when we are given an equation. The first step in computing a limit is always evaluation. To find the limit of f of x as x approaches a, the first step is always to evaluate the function at x equals a, so we get f of a. And if this is a number, then we're done. For example, suppose we want the limit of the function x squared plus 3 as x approaches 2. We evaluate by plugging in x equals 2 to get 2 squared plus 3, or 7. Therefore, our limit equals 7. Similarly, here we want the limit of the function 3x minus 3 divided by x plus 4 as x approaches 1. Our first step is to evaluate at x equals 1. When we plug in, we get 3 times 1 minus 3 divided by 1 plus 4, or 0 divided by 5, which is just 0. So our answer here is 0. Okay, so the first step in computing a limit is always to just evaluate. But what happens if when we evaluate, we don't get a nice number? Let's look at the limit of x squared minus 4 divided by x squared minus 3x plus 2 as x approaches 2. When we evaluate, we have 2 squared minus 4 divided by 2 squared minus 3 times 2 plus 2, or 4 minus 4 over 4 minus 6 plus 2. We get 0 divided by 0, which is not a nice number. We use the brackets around 0 over 0 to indicate that this isn't a valid number. Here's the big idea. We can never say that a limit equals 0 divided by 0. If we evaluate and end up with 0 divided by 0, then we must investigate further to determine if the limit exists or not. Simplification may be possible. So let's return to our example of x squared minus 4 divided by x squared minus 3x plus 2 as x approaches 2. Notice that we can factor both the numerator and the denominator. We can rewrite the numerator as x minus 2 times x plus 2, and the denominator as x minus 2 times x minus 1. We can then cancel the x minus 2 term from top and bottom. We are left with the limit of x plus 2 divided by x minus 1 as x approaches 2. And now when we evaluate, we get 2 plus 2 divided by 2 minus 1, or 4. So our limit equals 4. Our first big technique for dealing with a limit that yields 0 over 0 is to factor. Let's learn one more new technique, which is great for functions involving square roots. It's the technique of rationalizing. Here we have the limit of 3 minus the square root of x divided by 9 minus x as x approaches 9. Remember that our first step in computing a limit is always to evaluate. When we plug in x equals 9, we get 3 minus the square root of 9 divided by 9 minus 9, or 0 over 0. We must go on and investigate further. Our new technique is to rationalize. I'm going to go to a fresh slide just to give us some room to work. Now, we want to find the piece of the function which contains the square root, either the numerator or the denominator. In this problem, it's the numerator, which has the square root. Now we're going to multiply on top and bottom by the same quantity, except we're going to change the minus sign to a plus sign. So we're multiplying on top and bottom by 3 plus the square root of x. In the numerator, let's expand. We have 9 plus 3 times the square root of x minus 3 times the square root of x minus the square root of x times the square root of x. In the denominator, it's actually best to be lazy here. Don't multiply these pieces together. It's best to leave them as the quantity 9 minus x times the quantity 3 plus the square root of x. Let's simplify the numerator. Notice that the 3 square root of x minus 3 square root of x will cancel. And the square root of x times itself simplifies to just x. So we have the limit as x approaches 9 of 9 minus x divided by 9 minus x times 3 plus the square root of x. As in our last example, we can cancel the term 9 minus x from top and bottom. We are left with the limit as x approaches 9 of 1 divided by 3 plus the square root of x. Now we can evaluate at x equals 9, and we get 1 divided by 3 plus the square root of 9, or 1/6. Great. So you have survived your first calculus video. You have a few follow-up questions to complete for class, where we will continue learning techniques for limits that yield 0 over 0. I'll see you then.